Welcome to A4N, or ANNNN, the Artificial Neural Network News Network, the show about the latest developments in AI, machine learning, and data science, where we both introduce technical aspects as well as discuss the social implications of these advances. In today's inaugural episode, we'll be covering real-time facial recognition that may spell the end of privacy, cheating in the famed Kaggle data science competition platform, deep learning algorithms that predict protein structure, and finally using data both to hire software engineers and to become an AI researcher yourself. My name is Jon Krohn. I'm here with my co-hosts Andrew Vlahutin, Grant Beyleveld, and Vincent Petaccio II. Let's get this started. In our first segment, global headline news, we have some maybe disturbing news out of the Metropolitan Police Force in London.
Yeah. London's been known for a long time for its excessive, many would say, use of CCTV in monitoring the goings-on in the city. We've seen, what's his name? Banksy. How did I forget Banksy? Seen Banksy have some commentary on that in some of his art. And it seems like they're taking this to the next level by introducing live facial recognition into the system. This is obviously very concerning to privacy advocates and a lot of data scientists and machine learning practitioners, particularly in the context of what's happening to that data. What are the implications of using this type of technology to identify and pursue criminals? And, the Metropolitan Police, one of their representatives in this article, they talk a lot about the justifications for using it. And what they talk about is they keep pointing to public perceptions and the opinions of the public about this. The stat that they talk about is, here's a quote. They say that 80% of people surveyed backed the move. And I find that kind of concerning. I don't really feel like that's a very convincing argument because, how many people are using online platforms with extremely questionable and potentially dangerous privacy implications?
And there's also another spokesman. So the Met themselves say that the system was 70% effective at spotting wanted suspects. So, we're kind of getting to high numbers, reassuring numbers. Then in fact, someone at Essex University, Professor Pete Fussy, he was fussy about his results. So he did a independent review of their public trials on behalf of the force, and he found it was only accurate in 19% of cases.
Yeah.
And he says, I stand by our findings. I don't know how they get to 70%.
Yeah, one of the really concerning parts here is the Met themselves say that there is a false identification, so a false positive, in only 1 in 1,000 cases. And that might sound low, but hilarious. If we put that in a city with millions and millions of people, you're talking about thousands, tens of thousands of false positives every single day.
Yeah.
People who could be pursued, have their face tracked in a database indefinitely with unknown long-term consequences because of this type of error rate. I wouldn't want my face in it.
Yeah, at that logic, every single train that comes into a station on the subway is going to have one person flagged every single morning.
Yeah.
Flagged erroneously.
Yes.
Yeah, and they talk in here about they mention that it's less effective at nighttime and works best with good daylight. And to me, that sounds pretty consistent with a known problem in computer vision, which is that those with dark complexions, particularly minorities who are already disproportionately affected by this type of technology, by which I mean mass surveillance and law enforcement more broadly, it seems like they could be at a higher risk for these false positives.
And criminals tend to walk around during the day, not ever at night.
Right.
Exactly. It's convenient.
And look directly into the camera.
So, new trick is smile for the camera and do your crime in the daylight, I guess.
Yeah, and a big part of this as well that I am concerned about is where they're deploying it. A big problem we have here in the United States is that we tend to have this positive feedback loop of law enforcement targeting areas that are known for having high rates of crime, which is defined by increased police presence. And so you have the targeting of certain vulnerable populations by police, which results in greater purported rates of crime, which is then used to justify greater police presence in these communities. And I think we're seeing the same thing here because Someone named Mr. F. Grave from the Met says, quote, "The Met will begin operationally deploying live facial recognitions at locations where intelligence suggests we are most likely to locate serious offenders," unquote. So I have very real concerns about the same kind of situation happening where we end up in this positive feedback loop of catching people in the same locations that we've historically defined as high crime areas because of discriminatory policing.
A funny example, not an interesting example, maybe I shouldn't say funny example, but talking about putting cameras in areas where you're likely to find people. A couple of years ago, these technologies started to be used in China. So China is a leader in facial recognition AI technology. They have access to a lot more data than people in the West. So various levels of government are comfortable with sharing data with state-backed corporations. And so two of the biggest unicorn startups right now are actually Chinese facial recognition companies. And so they might be more advanced than what we have in the West. They also have armies of people labeling cheaply in China. So that provides stronger data sets. And anyway, so it's been a couple of years that the Chinese government in various places has been deploying this kind of technology. Most recently, we have it come up as being deployed to en masse surveil the Uyghurs. I'm probably mispronouncing that, but Turkic Muslims in the west of China. And years ago, already, in a slightly less nefarious sounding use, but an early use, they were putting these cameras at beer festivals. So as you entered a beer festival, everybody had their face detected by a face recognition camera. And this was kind of like an early use case where they were like, we successfully found 3 people who had been on the lam for years. Anyway, so I guess it's been around for a long time, and I'm not sure that that this is something we want to be following China's lead on and having this kind of mass surveillance.
I mean, if we're going to follow leads, Russia just deployed this in Moscow. It's apparently the biggest ever deployment. Moscow has something like 160,000 CCTV cameras, and they're rolling this out citywide. It's also worth noting, I guess, that this approach has been used on archival footage for a really long time. So these approaches are novel in the sense that they're happening sort of real time, which makes the process a little different. In archival footage, you always have the opportunity to go back and double check that you are actually spotting the person you're looking for, or whatever it may be.
Yeah, I mean, one of my concerns, just more broadly, is that we're entering a regime where we are using our technology. Thank you. Yeah, a regime in which our technology is being used to ostensibly keep us safe, but is in actuality creating a false sense of danger in the world, which makes us more vulnerable to exploitation by these types of technologies. So, for example, I think about Ring and all of the controversy around Ring right now and how it's being used. But Ring, the home security
Amazon's
service,
doorbells.
Yeah, so they partner very closely with law enforcement to the point where you can directly give law enforcement unwarranted access to your footage, and law enforcement agencies have been given free Ring products by Amazon to distribute to the community.
Wow.
So it's turning into a warrantless mass surveillance program.
Wow.
Meanwhile, we also have apps like Citizen, which, in my view, give people an unrealistic sense of danger in what are actually pretty safe communities by alerting them to every time someone kicks over a trash can or whatever. And I think that those types of things can give us a false sense of insecurity, which make us perhaps a little more comfortable with really invasive and potentially dangerous technologies like live facial recognition.
I had a happier example that we could share as well. I guess maybe not entirely happy, but it also isn't exactly real time. But they were recently, I saw a piece about a group that was using facial recognition to scan thousands and thousands of old photos of concentration camps during the Second World War. And then people would come through with families of their loved ones who were lost. And using this database, you could then find that person's image in a vast trove of thousands of images. Perhaps they're in the background, they're small, you wouldn't really notice them. And that kind of helped to, for people who had lost loved ones during the Holocaust, they could then trace back and find out what actually happened to them, like which camp might they have been sent to, where did they actually die. A little bit of sort of clarity on what happened to people, which I thought was kind of a nice use of the technology.
Yeah.
So not always for bad. But.
For sure. I think where I get concerned is when governments have access to this type of data, that the genie gets out of the bottle in such a way that we don't necessarily know how the data will be used in the future.
Right.
You know, as policies change, I mean, look at 9/11 and the Patriot Act and how many of the decisions that came in the legislation that followed that we now regret but can't really turn back, you know.
And you get in the situation, the false sense of security that you described, where you think, okay, well, these things are in place, and then you don't want to be the politician that reverses this decision, doesn't allow Amazon rings to be recording in the neighborhood, and then all of a sudden there's a bit of crime, and that politician is the bad guy. Yeah,
you're soft on crime.
Yeah, exactly.
Right.
And so we've talked a lot about the social implications. We also want to make sure we are all data scientists here, and so we want to spend a little bit of time also talking about technical aspects. And so for this kind of work, any kind of this facial recognition technology, of course, we would all assume they're using convolutional neural networks, which are, as far as we know, by far the state-of-the-art way to be doing any of this kind of visual spatial recognition. And we've mentioned some of the drawbacks of that technique. It is data hungry. So in situations where you have some groups that are undersampled, or we don't have a lot of training data that are taken at nighttime, we can end up with a lot of flaws in these kinds of situations. A lot of wasted time maybe on behalf of the Met officers who are patrolling the train station or whatever. And then also, a lot of, those kinds of false positives lead to, distress among the civilians as well for no reason. So I don't know if there's anything else people want to talk about in terms of techniques. Maybe we don't need to get into too much detail.
Yeah, in the article, they go a little bit into detail about how they're doing it by identifying what they call face prints. So they identify a number of facial key points, corners of the eyes, top of the ear, tip of the nose,
right,
ends of the mouth, and use those and their relationships in space to one another to identify a unique face print for an individual, which they compare against a database.
I wonder how much of that doesn't come down to just kind of vector math in data science. It might, the way I understand it can be done as well is to use a convolutional network to essentially transform an image of someone's face into, say, a 64 length vector of numbers. And then we can just look for other 64 length vectors of numbers which represent other people's faces in the database that are close close mathematically to that vector. Yeah. And in that case, various numbers in that 64 dimensional vector in a sense represent features of the face, but not sort of in the classical way that we come to recognize them.
Yeah. So to make this work, it sounds like a kind of way that this could be made to work efficiently. In order to have the initial convolutional neural network be trained, we're going to need training data of lots of points on the face labeled well, which as I explained earlier, China is a leader in getting these kinds of labels. But I'm sure there's no doubt that there are other labeling farms producing that. So we can use that. And then you can run that across a set of known felons. And supposedly this technology is only being used on databases of severe criminals, whatever that means. And somebody gets to arbitrarily decide that threshold. But then that can be used to annotate those images. Those could be put into, say, a 64 length vector. And then you have a very efficient way of searching over all of the data that you're grabbing in real time. Mm-hmm. All right, so that is enough coverage of our first topic. We have more coming up for you next.